Okay, so a lot of people didn't like this matrix notation and even more hated it. So we're going to do the dot product using just simple algebra here. So here, let's remind ourselves, r hat was cosine theta I hat plus sine theta j hat, right? And r dot r is equal to cosine theta I hat plus sine theta j hat multiplied by cosine theta I hat plus sine theta j hat. Okay, so now we can go ahead and do some simple foiling. So we can call this A and we can call this B. So we see that this whole expression is the same as A plus B times A plus B, which in other words is also A plus B squared. So from high school we could say this is A squared plus 2AB plus B squared. Or taking it a step back, we see this is A squared plus A times B plus B times A plus B squared, where the middle two terms are basically the same. Order does not matter in multiplication. So that's the same as 2AB. Now, let's go ahead and plug everything in. So we see over here the first term for this dot product, r hat dot r hat is equal to cosine squared theta I dot I, that will be A, plus cosine theta times sine of theta I dot j plus sine theta cosine theta j dot I, and turning a little over, plus sine squared theta j dot j. Now remember how the dot product works. Only components that are alike dotted upon themselves will equal 1. So I dot I is equal to 1. I dot j is equal to 0. I dot I is 1 because I is being dotted with I, meaning I is being dotted with itself. I dot j are two unit vectors that are not the same. So this whole entire term is 0. Likewise, j dot I is also 0. And hence j dot j, because they're the same, is equal to 1. As a result, we see that r dot r is equal to cosine squared theta times 1 plus sine squared theta times 1, which is equal to cosine squared theta plus sine squared theta. But this is just a trigonometric identity, which is equal to 1. So we see that any unit vector dotted upon itself, or in other words its magnitude, must equal 1. Another term for that is called unity, when the length of a vector is equal to 1. Okay,